derivatives with logarithms, chain rule, and a quick and easy method. This quick and easy method, if you've watched my other ones, I say the same thing. It's just a way of doing the chain rule without using notation. It makes things much quicker, easier, uses less space. You can give it a go if you're inexperienced, but I would try the other ways first to learn it. This is just something when you get more proficient at it. It can actually be easy to learn this technique first to start off with, but you should learn proper notation as well. I'll get on with it anyway. So here we have a function, log to the base of a, x. When you derive that function, you get 1 over x log, natural log of a. That's just it. You have log to the base of a number, x, your variable, and then when you derive that, you have 1 over your variable multiplied by natural log of your base. So we can start with an example. We have, this isn't going to be an example of the chain rule. This is just going to show you quickly exactly what it's like. It's exact same as what I've shown above, except this just has a number. Hopefully, if you don't understand, you understand now. The base just becomes where the a is, because that's where the a is the base. You have log to the base of 10 x. When you derive that, you have 1 over x multiplied by natural log of the base. As simple as that. It might be making it sound more confusing than it is. I might be speaking gibberish. Either way. Example 2. Y equals log to the base of 2 x to the power of 3 plus x. This method, you basically just write it out as you go along. When you do the chain rule, you derive the outside and leave the inside the same. And then you multiply it by the derivative of the inside. If you have more, you just keep doing the same. You derive the outside, leave the inside the same, and then you multiply that by the second outside. Like once, I have an example of that later, but I'll show you just this for now. Like I said, you derive the outside while leaving the inside the same. So we derive log 2 with respect to all of this. If we're deriving log to the base of 2, you end up with 1 over. This is the variable. And then ln 2. I'll show you exactly. This isn't the completed version, but that's just it. The variable x becomes down here. I've just put in what that variable is. See how I've done that? Log to the base a, x. Log to the base 2, x to the power of 3 plus x. Where they've had an x and I've brought it down and multiplied it to a natural log of the base, I've just brought down this whole mess and multiplied it by the natural log of the base. Then you multiply it by the derivative of the second function, which is in the inner function. So that would be 3x squared plus 1. Rearrange it. Make it look a little neater. And that's it. That's the first derivative. Takes up just about 3 lines. Admittedly, I'm using a whiteboard marker, so it takes up a lot more space, but that's the idea. You don't need notation, you don't need to carry on. You just do the question in your head, do it fast, and then you're done. Example 3. Say log y equals log to the base of 5 sine x. Okay. Again, we derive the outside. Put the variable down here, or whatever's in the brackets, and multiply it by ln of the base. Just like before, this is our this is what we're doing it with respect to, and that's what comes down here and multiplies onto ln of the base. All under 1, obviously. And then you multiply that by the derivative of the second. You multiply by the derivative of the second function, which would be cosine x. Rearrange that, you get cosine x over sine x ln 5. That's it. Very quick, very easy. Example 4. Y equals ln log the base of 6 e to the x. Here we have a function within a function within a function. So, as I would usually do it, you derive the first function while keeping the inside the same. Then you multiply it by deriving the second function while keeping the inside of that the same, and then multiplying it by the derivative of the third function. Essentially, you derive the outside and treat everything inside like a variable. So that's what we're going to do. Derive log, natural log. Derivative of natural log is 1 over x, but that's log x. Here we have log, that's natural log when you have x in the brackets, but here we have the natural log of log 6 e to the x. So that's what we're going to write. Log to the base of 6 e to the x. That's our variable. Well, we're treating it as our variable. Then we multiply it by the derivative of the second function while leaving the inside of its brackets the same, which would be deriving log 6 while keeping e to the x the same. 1 over e to the x ln 6. And then multiplying that by e to the x. Well, derivative of e to the x, which is e to the x. I'm doing the same things as I've done before. I'll bring up the wheel. I've done the same things as I'm doing before. The derivative of log to the base a x is 1 over x log a, natural log a. Just like here. Derivative of log 6 e to the x is 1 over e to the x log of the base, natural log of the base. Same thing. Now, because we're multiplying this all together, we can cancel out the e to the x and cancel out this e to the x because it's multiplied. Therefore, if we rewrite this, we end up with 1 all over ln 6 log to the base of 6 e to the x. And that is the first derivative of that. That's it. I hope this video helped. Thanks for watching.